This is Emma. Emma's in a state known as homeostasis.
Am I?
You are. Well, Emma, your endocrine system is hard at work trying to keep your body in balance. The hypothalamus is the brains of the whole system.
What's that?
The endocrine system is a collection of glands that secrete hormones into the bloodstream. Hormones are chemical messengers secreted from one location and carried by the bloodstream to a target location. Hormones come in the form as proteins or steroids, and the hypothalamus is the region in the brain that controls and monitors your glands.
Steroids? Are you calling me fat?
No, silly. Steroids just mean that those hormones dissolve in fats and pass through the target cell, the nuclear membranes, and bind to the receptors within the nucleus, which changes the expression of genes. On the other hand, protein hormones dissolve in water and bind to the receptors on the surface of a target cell. You don't understand, do you?
Nope.
Let's take a look, shall we? Pretend to eat an apple. The glucose from the apple gets absorbed into the bloodstream after being digested. The increase in glucose levels causes the beta cells of the islets of Langerhans in your pancreas to secrete insulin. This lowers blood glucose because when insulin is secreted, it stimulates the liver to convert glucose to liver glycogen, it stimulates the muscles to convert glucose to muscle glycogen, and it stimulates body cells to become more permeable to glucose. When your blood glucose levels are low, the alpha cells of the islets of Langerhans in your pancreas secrete glucagon. Glucagon causes stored glycogen to be converted into glucose and decreases a cell's permeability to glucose, resulting in an increase in blood glucose levels. Insulin and glucagon are antagonistic pairs that maintain glucose levels at homeostasis. The whole process is a self-correcting system called negative feedback.
Okay, is there another example of antagonistic pairs?
There sure is. The parathyroid hormone and calcitonin are antagonistic pairs that help maintain and regulate blood calcium levels to homeostasis. The hypothalamus secretes parathyroid hormone releasing factors to the anterior pituitary gland. This stimulates the anterior pituitary gland to secrete parathyroid hormone in order to increase blood calcium levels. This stimulates the intestines to absorb more calcium. It stimulates the kidneys to reabsorb more calcium before excretion, and stimulates the bones to release calcium. When blood calcium levels are too high, the hypothalamus stops secreting parathyroid hormone-releasing factors and starts secreting thyroid-releasing factors. This stimulates the thyroid to secrete calcitonin. Calcitonin stimulates the intestines to absorb less calcium. It also stimulates the kidneys to reabsorb less calcium before excretion, and it stimulates bones to deposit calcium.
If these are negative feedback loops, what's a positive feedback loop?
Good question. Positive feedback is used to magnify, not correct, an original stimulus. For example, oxytocin is secreted to stimulate uterine contractions.
So oxytocin helps me give birth?
Correct. When you're in labor, oxytocin will help you squeeze your baby out of your tiny cervix. Those suckers will just pop right out.
Stop! You're embarrassing me in front of the Justin Bieber, and it's stressing me out.
Emma, is your heart racing at the sight of Justin? Are you short of breath? What you're going through now is denial. And the result of epinephrine and norepinephrine, these hormones are fast-acting, whereas most other hormones are slower. Hopefully one day in the very near future, you'll outgrow your bad taste in boys. One day when you're ready, I'll show you what a real man is. Oh look, there goes one right now. Now that's what I'm talking about. Oh.
He looks like my grandpa. Was your heart racing? And were you short of breath at the sight of that, Grandpa?
Well, maybe you should introduce us sometime. Now that we have seen what homeostasis is in the body, let's examine what hormone imbalance would be like. An imbalance of human growth hormone can cause abnormal growth. For example, gigantism is the excess secretion of human growth hormone during childhood before the bone growth plates have closed. This causes the individual to continually grow even through adulthood. Dwarfism is a low secretion of human growth hormone during childhood.
Maybe that's the reason why I'm so puny.
At your age, this is perfectly normal, but you should be aware of other common hormone disorders such as hypothyroidism and hyperthyroidism.
Oh, I know this one. Hypothyroidism is when you have a small thyroid, whereas hyperthyroidism is when you have a large thyroid, right?
Generally, hypothyroidism is when too little thyroxine causes a lower metabolic rate. Hyperthyroidism, or Graves' disease, is an excess of thyroxine that causes a higher metabolic rate. There are many other endocrine disorders, and for more information, refer to your handout, Emma.